Hi guys, I wanted to take a second and go through this problem with you. Just so you have like one more example of an isotope problem that's a little bit more complex. And so here we have the question. Chlorine has two isotopes, chlorine 35 and chlorine 37. The average mass of chlorine is 35.45 AMU. And so that's, our atomic mass. And so what is the natural abundance of Cl35? Okay, so what we're asking is like this number right here, 17. So, I guess if I go back, it doesn't keep the recording. So here we go. 35 is the mass number. Number of protons is 17. These are all neutral atoms unless it specifies that it's an ion. So we have 17 electrons. And then to find the neutrons, we take the mass number, 35, minus the number of protons, 17, and we're going to get 18. So there's 18 neutrons in chlorine 35. And to get the isotope weight, one of the things that's kind of a trick for these is just assuming that the electron weight is negligible. They're so small. Each number of proton equals 1 AMU, and the number of neutrons equals 1 AMU. And so total we've got 17 protons, 17 neutrons. And so this is going to weigh about 35 AMU. Okay? Okay, so we're going to do the same thing for chlorine 37. Mass number is 37. Proton number is still the same, so it's 17, right? Because if the number of protons changes, the identity of the element changes. Electron 17, this is not an ion. And then this time we're going to go 37 minus 17, and so the number of neutrons is 20. Okay, so that gives us an approximate isotope weight of 37. Remember, we've taken the number of neutrons, the number of protons, and added those together, so we get 37 AMU. Okay, now if we wanted to, we could calculate the exact weight. Okay, and so the way we would do that is for chlorine 35, right, the number of protons equals 17, and we times that by how much a proton weighs, 1.007 AMU, and that equals 17.119 AMU. And then we say, okay, the number of neutrons in this atom is 18, and we multiply that by 1.009 AMU, or the exact weight of what a neutron weighs, and we get 18.162 AMU. And the last one is the electrons, and we've got 17 electrons, and we times that by 0.0006 AMU, and that equals 0.0102 AMU. We add these three numbers together and we get 35.291 AMU. Okay, so that's the exact weight for chlorine 35. And so that's why sometimes a problem will give you the exact weight, but I just find it a little bit easier to work with these smaller numbers. So we're just going to work with these approximate weights as we go through the problem, just for simplicity's sake. Okay. Okay, so when we're calculating atomic masses and also fractions of abundance or masses, we use this equation, right, where we've got the atomic mass from the periodic table, which that information was given to us, and then the fraction or decimal of chlorine 35 times the mass of chlorine 35 plus the fraction of 37 chlorine times the mass of 37 chlorine. Okay, so I've taken from the problem and I've added the information that we know. Okay, so we know from the periodic table that a sample of chlorine, the atomic mass is 35.45 AMU. Okay, and we want to find this, the fraction of chlorine 35, or the decimal. We're going to times that by the weight of chlorine 35, so 37 AMU. And then in our problem, like we weren't given the fraction of chlorine 37, but we were given that sample, the mass of that is 37 AMU. Okay, so there's kind of a trick because with this equation, we've got two variables, right? We've got the chlorine 35 and then we've got the chlorine 37. Well, I know that 100% of the sample contains chlorine 35 and chlorine 37. Okay, I also know that we want to deal with the fractions or the decimal forms of these numbers. And so instead of using percentages, what I'm going to do is just use 1. Okay, so 1 equals 35 chlorine plus 37 chlorine. Okay, so I want this number, right? So what I'm going to do is solve for this one. Okay, so what I get is 37 chlorine equals 1 minus 35 Cl. Okay, and so, whoops, I said that right and wrote that wrong. So this is 37, I'm just going to cross that out. 37 chlorine equals 1 minus 35 chlorine. Okay, so now in my original equation, what I can do is take this information right here and substitute it in for that number right there. Okay, so if I go to the next slide, what I've done is I've done that, right? So up here I've got 35.45 AMU, or how much that sample weighs. I've shortened that to just say 35 chlorine times the isotope mass, so 35 AMU. Then I've taken and substituted this in for 37 chlorine, okay, times the isotope mass, 37 AMU. So to simplify it even more, I know we can use that symbol, which is fine, but I'm just going to say let X equal 35 chlorine. And that way it gives you a formula that you're used to seeing a little bit more, right? Because we've got X's. So every place I have 35 chlorine, I put X. Okay, so now what that does is it reduces the equation down so we only have one unknown instead of two, right? And our only unknown is this 35 chlorine. Okay, so now it's just an algebra problem and we can solve it. So make sure you pay attention to your significant figures and also your units. So I'm just bringing 35.45 AMU down equals, I'm multiplying these two together, and so I get 35 AMU X. Okay, and then this one, this multiplication right here, I have to distribute to each one of these. Okay, so that's plus 37 AMU minus 37 AMU X. Okay, now I'm going to simplify and combine like terms. Okay, so over here I've got AMUX, and right here I've got AMUX. So I'm going to combine those two, and that gives me negative 2 AMUX. And then I'm solving for X, so I want to take this 37 and move it over to the other side. So here I'm going to subtract 37 AMU from both sides. Okay, so that gives me negative 1.55 AMU equals negative 2 AMU X. Okay, last step, we're going to solve for X, right? So I'm going to take and divide this by negative 2 AMU and divide this by negative 2 AMU. And what I get is X equals 0.7 Okay, or if I convert it into percentages, 77.5% natural abundance. ABUN, abundance of chlorine 35. Okay, and so if I take this, right, and I've got 77% of chlorine 35, I can also go 100% minus 77.5% gives me 22.5% chlorine 37. Okay, so that's like a lot going on that slide. If I go to the next one, so what I found is when I take a whole sample of chlorine 35, right? So I've just like scooped in the dirt and grabbed this stuff. What I found is 77.5% of it is chlorine 35 and 22.5% is chlorine 37. Now this only works because there's two isotopes, right? So I know those two have to total up to 100. Okay, if I was paying attention to sig figs, significant figures throughout, there's actually only one significant figure. So I would say 80% chlorine 35 and 20% chlorine 37. Okay, so if we go back to the question, chlorine has two isotopes, chlorine 35 and chlorine 37. The average mass of chlorine is 35.45 AMU. What is the natural abundance of chlorine 35? And so our answer is 77.5% of chlorine atoms are chlorine 35. Okay, so that's our answer. Round up one significant figure, we get 80%. So either of those answers will work for this, depending on how close you're tracking your significant figures. So I hope that kind of helps. If you want, leave some questions in the comment section and let me know if anything was confusing. Good luck.